1. Many worlds interpretation, MWI, core idea. With every measurement, the universe splits into multiple parallel universes. Each of these universes represents a different outcome of the measurement. Wave function. Everett proposed that every system is part of a universal wave function. This wave function does not collapse, but instead branches out. Determinism and randomness. The universal wave function is deterministic, meaning everything follows precise laws. However, from the subjective perspective of the observer, it appears random. Parallel worlds. Each measurement causes the universe to split into different branches, each corresponding to a possible outcome. For example, in Schrödinger's cat thought experiment, the cat is both alive and dead, but each state exists in a separate parallel world. 2. Many minds interpretation. Mind splitting. With every measurement, the observer's mind splits into different versions, each experiencing a different outcome. Consciousness and subjective experience. According to this view, with each measurement, a person exists in many different universes, but these copies are unaware of each other. External versus internal perspectives. External perspective describes the mathematical and physical nature of the universal wave function. Internal perspective describes the subjective experience of the observer, who is only aware of a single outcome. 3. Technical details. Superposition. The wave function, PSI, represents multiple possible states at once, and each state is realized in a different parallel world. Eigenfunctions. Each parallel world is one of the eigenfunctions of the wave function ESI. Measurement and interaction. Measurement is defined as an interaction where one subsystem becomes correlated with another. This interaction is irreversible and affects the evolution of the subsystem. Criticisms and challenges. Why can't we see parallel worlds? Everett did not clearly explain why we experience only one reality if multiple worlds exist. Decoherence. The process of decoherence is used to explain how parallel worlds separate and become unobservable to each other. Energy problem. If an infinite number of parallel universes are being created, infinite energy would be required. Since the total energy of the universe is finite, this remains a problem for the theory. Views of prominent thinkers' supporters. Famous physicists like Stephen Hawking, Murray Gell-Mann, and Richard Feynman have supported or expressed interest in MWI. Opponents. Roger Penrose has criticized MWI and does not accept it. Popularity. The Copenhagen interpretation is the most widely accepted view of quantum mechanics, but MWI ranks as the second most popular interpretation. 6. Interesting perspectives. Connection with psychiatry. Some scientists have suggested that altered states of consciousness, like dreams or schizophrenia, might be linked to parallel universes. Fred Alan Wolf even suggested that parallel universes might be between our ears. Copies of ourselves. In parallel universes, not only events but also people are duplicated. These copies exist independently of each other. 7. Conclusion. Everett's many worlds interpretation suggests that with every observation, the universe branches out into infinite parallel universes. This theory addresses the role of the observer, wave function collapse, and the nature of superposition in quantum mechanics. Despite its radical nature, MWI is taken seriously by some physicists and remains a fascinating perspective on the nature of reality.